Hello all of you. Our next topic is the recursion. Now in this session we will see what is recursion. We will refer to example of this finding the factorial of a number and a Fibonacci series. Also we have seen the Ackermann function for the quick sort and the merge sort. Now first, what is recursion? Recursion is the process by which a function calls itself. Here is a sample code is written void main integer I is equal to 5 printf I, and again I am writing the main. It means this main is calling the main itself, means it is calling the itself. That's why it is known as a recursion function. What is the advantage of it? Is easy for the writing the complex program. It will contain the less number of code lines. But what is the disadvantage of writing the recursive function? Recursive code is difficult to understand and debug. So it is necessary that termination condition must be there in the recursion function. Otherwise, it will go into the infinite loop. But main disadvantage is execution speed will be decreased because of the function call return activity many times. Now we will see the example of the factorial of a number. Factorial of a number, here we are writing enter a positive integer. Scanf, we are taking the factorial of a number. Now if I will write the factorial of a number, the factorial how we are calculated. Suppose I am writing the factorial of the 4 factorial. So 4 factorial is nothing but actually 4 multiplied by 3 multiplied by 2 multiplied by 1. This is the 4 factorial. So if I am considering 4 factorial as n factorial. So actually I can write as n multiplied by n minus 1 again multiply by n minus 2 till 1. So this is the factorial of a number. Now here you can see, as soon as you, another way you can see, if I am finding the factorial of 4, I can see that this 3 into 2 into 1, it is also considered as a 3 factorial. So same operation I can write in the another way, that is n factorial is equal to n into n minus 1 factorial. This is also another way for writing the function. It means that same factorial, now I am calling on the n minus 1. So same concept we will use for the programming. Here you can see that we are calling the function fact. So it will return the long integer number. So return type is long integer. Fact is a function name. I am passing one value integer n. If n is greater than equal to 1, then it should call the factorial function, that is on the n into fact of n minus 1 as we have written over here. And if it is 1, if n is equal to 1, then it must return 1. Second is the Fibonacci series. Now Fibonacci using the recursion. What is the Fibonacci series? Again the Fibonacci series is writing the 0, 1, 1, then 1 plus 1, 2, 1 plus 2, 3, 3 plus 2, 5. It is something like this. So it will generate as many Fibonacci numbers. So how can we write? That is, enter the nth Fibonacci number. If n is less than 0, Fibonacci of negative number is not possible. Otherwise, Fibonacci of number. Now Fibonacci of number is, if number is equal to 0, it should return only 0. If number is equal to 1, return 1. Otherwise, Fibonacci of number 1 minus Fibonacci of number 2. Next topic, that is the Ackermann function. Now, Ackermann function is the simplest example of a well-defined total function which is computed but not primitive recursion. It providing a counterexample to the belief in the early 90s that every computable function was also primitive recursion. Now, Ackermann function is a well-known recursive function that can be defined on the m and n. That is, m is greater than equal to n and n is greater than equal to n as well. If m is equal to then it will call the function Ackermann mn, but the value will be n plus 1. But if m is greater than 0 and n is equal to 1, then it will call the Ackermann function on the m minus 1 and the n value is 1. In third case, it is if m is greater than 0 and n is greater than 0, then Ackermann function mn can be calculated as Ackermann m minus 1, and again for the n, Ackermann m n minus 1. Now here is the simple example. The same operation we will write in the program form. We are taking two value m and n. If m is equal to 0, then the output should be n plus 1. That is n plus 1. If m is greater than 0 but n is equal to 0, then it will call m minus 1 on the a 1. Otherwise, it will be m minus 1 occurs on m n minus 1. Now the quick sort. Quick sort is a sorting technique we basically use for performing or arranging the data in proper order, either ascending or the descending. Now, quicksort is a highly efficient sorting algorithm and is based on the partitioning of array of data into smaller array. Quicksort is a divide and conquer algorithm. At each step of the method, the goal is to place a particular record in its final position within the table. In doing so, all the records which precede this record will have smaller keys, while all the records that follow it have a larger keys. This particular record is termed as a pivot element. Now the same process can then be applied to each of the subtables and repeat until all the records are placed in their proper position. Now what is a pivot? There are many different versions of the quicksort that pick pivot in the different way. Always pick first element as a pivot. In our case, we have considered this version. Always pick last element as pivot implemented below, and pick a random element as a pivot or a pick median as a pivot. Now quicksort partition an array and then calls itself recursively twice to sort the two resulting subarray. Now this algorithm is quite efficient for larger size data sets. Its average and the first set complexity are of 0 and square. It is not n2, it is n square, where n is the number of items. Now here we will see the simple example. This is my array. I am storing some value. Suppose 42 is my first element. I am considering 42 as my pivot element. What I will do, I will set two pointers. One is lower bound, another one is a upper bound. Every time I will compare lower bound and upper bound with the 42. If lower bound value is less than the pivot value, then it will be incremented. Otherwise, and when it will find the value of the LB is greater than the pivot, then it should stop. Similar for we are doing for the upper bound. If upper bound element is greater than the pivot element, it should increment the upper bound pointer. It will decrement the upper bound pointer by 1. Now in this example, we will see that currently pivot is pointing to the 42 and lower bound is also pointing to the 42. As we compare, increment lower bound first. It will compare 23 and 42. So 23 is smaller than the 42. So it will be remain as it is and it will increment the lower bound. Exactly similar way, again it will increment the I, that is the lower bound, to the 74. So it will compare the 74 and 42. So 74 is greater than the 42. So it will be kept as it is. Now it start with the J, that is the lower bound pointer. So 87 is compared to the 42. So 87 is greater than the 42. So 87 will be as it is. Then it will decrement the J pointer by 1, that is 99. 99 is compared with the 42. So 99 is greater than the 42. So it will be remain as it is and again J will be decrement. Now 36 and 42 will be compared. So 36 and 42, 36 is smaller. So in this case, what it will be, it will stop over there. Whenever this I is less than J, here you can say the condition. If I is less than J, then it will exchange the value of Ki and Kj. That's why value of 36 and 74 both are exchange and in exchange and it will be remain as it is. Now then after it will again compare 7 check with the I, that is 11 and 42. So again 11 is smaller than the 42 but and it will stop over there. Then 65. So I will be remain as it is. Then J will be decremented. 74 and 11 it will be as it is. 58 and 11 it will be as it is. 65 and 11 it will be as it is. Now at this point it will found that J will be first and then after I. In this case it will exchange the pivot lower bound, that is pivot element, with the G, that is 42 is replaced with the 11. exchange with the 11. In that case, you can see that 42 will be at its proper position. So now your array is partitioned into two sets. One array is the 3 element and other array is of total 6 elements. So now same algorithm will be applied for this portion, left portion and the right portion. Here is the recursive algorithm for the program. What is initially flag is equal to 2. Lower bound is less than upper bound. Lower bound will be I, upper bound plus 1 will be j. Value at the lower bound is considered to be your pivot, that is key. While flag is equal to true, increment the I until your k of I is less than key, and j will be decremented until k of j is greater than key. As soon as this complete, you have to check if I is less than j, then you have to exchange the value of I and j. Otherwise, you have to set the flag to be false. And after finishing, if flag is false, in this case lastly, it will exchange the value of kj with the lower bound. After performing all short, it will call the quick short, that is the same algorithm. Now the limit is pivot element, that is the first element, then lower bound and j minus 1, and another partition is j minus 1 to upper bound. And after performing quick short on both the algorithm, it will call the actual quick short algo on the KLB to the j minus 1. Here is the recursion function. Now mergers. The operation of the sorting is closely related to process of merging. Merge sort is a divide and conquer also algorithm, but merge means it will divide the data into the sections and then after it will start merging. Now here are the elements of the array. Split the selected arrays as evenly as possible. So here you can say first it will find the middle. It will partition in the two sections. In the next section, it will has the two partition. Again, it will find the median and it will create the two sub partition. Again, it will merge, divide and two partition. At this point, you can see that it will contains only single element. After reaching to the single element, it again start merging. It will compare the 521 and 724. Whichever is the smaller, that will be placed first and the second. Then again it will merge the another two partition, that is 2 and 98. So 2 and 98. Then after it will take these two array, it will merge. Exactly similar way it will perform on the right hand side and finally it will merge an array. This is the reference link. Thank you so much.